So, good afternoon. I would like to welcome you on our afternoon section. This section will be mainly about instrumentation and measurement systems, but maybe some topics will be a little bit different. And on our program, we have one industry partner from ST Microelectronics, and also we have 5 students' presentation from different scientific areas, so I hope the program will be interesting for you. So I would like to introduce you Mr. Jan Pistulka with his presentation, which deals with automotive systems.
Perfect. Thank you, Martin. And you kind of spoiled my first question because I wanted to wake you up a little bit after the nice lunch we all had. And that was kind of like, who recognized this logo? Because, you know, our products are usually somewhere hidden. They are not, you know, Apple, Google, Nvidia, Intel, BMW, but we are somehow hidden behind the scene. But you already introduced that. So my question would be slightly different. Who worked already with products from us? Wow, that's impressive, actually. That's really nice. Honestly, I did not expect that because, for sure, as everybody, also we have our, let's say, competitors. They are tough. The competition is tough. Always, Jan can, I believe, also confirm that to you. And, you know, presentation, first of all, I completely feel with you who's going to follow me. And, you know, I'm always nervous. So it's not an easy pose to stand here. I don't know how it was for you. For me, it's a little bit of thrill, a little bit of nervousness inside. But that's good. That's part of the deal. And when I was this morning coming to my car, opening it, you know, sitting inside, starting the engine, I was somehow, you know, thinking what I'm going to say to you as the first opening, let's say, statement. And I kind of came up with that for me personally, sometimes knowing a little bit what's under the hood, it is surprising, it is really nice that the car works the way it works, and from the first moment on. Because if you would know what all testing, as again I'm referring to you quite often, what all testing preparation is behind it, it's not definitely easy, and it is not a straightforward process, as it might seem. I will bore you with these topics, hopefully. And we will start slightly. I will introduce, let's say, who am I, who is the company that I work at, then a little bit really stick to the topic about the agenda, introduction about automotive. Because automotive, we know what does it mean in the big picture, but in the details, what's really the nitty-gritty of it, it's different market. It is different market, it is different approach, it is slightly different, so it's going to be kind of automotive. Please consider it as automotive 101, if you can, if you may, because it's going to be generic, but for sure, at the end, we will come to some implementation, and one of it you can also see here. Maybe we'll have during the Q&A session some time to, let's say, talk a little bit more about it, or you can also, if you want, touch it. So about me a bit. My name is Jan Pistulka. I was made here basically 9 years ago, almost 9 years ago. And the timeline, it's correct. Because I came from US, I was there as part of an exchange program. Highly recommend if you can do that. And then I came back. I was left only with my diploma thesis. Very nice. What do I do with the spare time party, you know? Hard decision, so I start to work. Enjoy the free time, I would say, if you may. But the work is also great. And that's why the timeline is correct. I started to work, you know, in the same year I graduated, and then at the same year, end of the same year, my boss asked me, hey, during your introduction, you know, interview, you mentioned you were free to go, you know, abroad. I said, yeah, sure. I went to Germany. He offered me to go to Germany. I was as FAE, Field Application Engineer in Prague. I was AE, AE Application Engineer. Slightly different story, slightly different topics. As an AE, you basically sit on the applications from the bigger perspective. You don't deal directly that much with the customers. You don't deal that much directly with all the design, all the parties. You're on your application. You do whatever is necessary for your application, but it's kind of narrower scope. As an FAE, on the other hand, especially as a FAE on key account customer in that case, I believe I can name that. In Stuttgart there is one big player beside Porsche. It's Bosch. I was at Bosch for almost 5 years, and there it's a different world. It's directly on site with the customer, so you need to deal with them. You need to react to their, let's say, question reactions all over requests. That means you need to work on the topic, but also communicate with them, bring the topic to your company, because you cannot deal with everything by yourself. The world is getting up, we'll see that. It's complex, and you need to involve the team. You need to involve it in the right way, at the right time, and that's basically all about the job. But for sure, sometimes you need to go down to the details, because you then need to explain it to the customer itself. Long story short, then I moved from FAE to system team, where I'm right now. My focus topics, some of them are listed here, because as FAE I was mainly on the microcontroller, but right now really from the system team, you name it, virtualization, microcontroller, software, power line communication, all different kind of aspects, security, big topic. That's, let's say, is now my play arena. Where do I work at? For sure, ST Microelectronics. Grounded or raised 1987 as a merger from two companies, SGS and Thomson. That's why the ST. And based already a little bit, maybe it's a French-Italian company. It has some bright side, downside as well, as normal. It is definitely not a startup. But sometimes the processes are startup-ish based on the nature of the company. There's some people like, some people don't like. I like it. I love it. And we're big. That's really not startup topic. We are, let's say, in the 20 biggest semiconductor companies, as said, you name it. Intel, NVIDIA, our direct competitor, TI, Texas Instruments, Analog Devices, Infineon, let's say all the kind of from the semiconductor point of view, the known players. But what makes us different is actually this point. We have our own manufacturing sites. That's not common. That's not common actually at all. Intel, TSMC, NVIDIA the same. Most of them are actually, let's say, giving the production to somebody else. It has bright and downside as usual. That's why also my question to you, why the stock? Because in this case, we can basically take care of our stock, of our production. We are not, let's say, dependent of the others that much. For sure, there's some dependency. Oh, I really don't like this chair here. And that makes, let's say, us different. But the downside of it is, if you imagine, let's say, manufacturing site, production line, in order for it to be profitable, it has to be at 80% at least capacity. Otherwise, you lose money. Being everywhere means also, R&D, reuse and develop. Like, ChatGPT made this presentation for me. And then we have, let's say, the fake it until you make it guys, sales and marketing. I'm officially part of the marketing, even though, you see my background is very, very technical. And then we have something which we call front end and back end. Just for your quick information, in the process, everything's done with a big pile of sand. From the sand, you melt it, you make a silicon, 99 point, a lot of nines, purity. You slice it, you make a, let's say, a wafer out of it, and with the wafer, you start, let's say, building up your chip. ACID, all these kind of processes are behind it. I'm not an expert, I will not tell you what's all about it, but basically the difference between the front end and the back end is The front end is until the chip is made. The back end comes and put it inside the package plus the testing, and then you can see it if after the please check that you can see it inside the package, because before that it was just what we called or what is called a bare die. Let's say naked chip, maybe bonding it's inside, depending on the variant. Because we are in Prague, we have for sure office also in Prague. And having said that, Automotive, that's my background. We have also a team there. And a couple of things I like about the office. A lot of promo, spoiler alert. First of all, you see the location. Superb location, Florence. Food walk from the city center, pristine, nice. The second thing is the people, the huge know-how which we have there, especially, I believe, inside the Automotive, because we have the application guys there. It starts with the microcontroller, high power. Let's say the last one is imaging people. Really, let's say, for me, something, and that was also my enabler for, after a year, being able to go, on site with the customer. A lot of facts. You can read it if you want. I will, let's say, just stick with one, and that's this time. It is super clean process. I was never there, but I've heard. And because right now, all what you see is just a huge line. It's super sealed. You cannot touch it. You don't see basically anything. But I have a story for you. It's a story from my boss. So 25-ish years old. The story is, not him. And the story is that basically 25 years ago, he was I believe he was at quality. And from time to time, let's say the production was, let's say, ramping up. And from time to time, there were some field returns. Unknown issue, random. Let's say for us, you can, I believe, confirm that the worst case scenario. If it's random, it sometimes takes a day. It can take a month to find out the root cause. Completely random. All the analysis was triggered. Everything was done. And do you know what was the root cause? Any ideas? I have to highlight. At that time, there was no, let's say, continuous machine, but everything was kind of, one process, take it with, I will carry it to the next one, and that's one. It was actually the purity. Because there was a guy, let's say, Joe, and Joe was doing this job, let's say, every second week. And he liked to eat. So whenever he carries the tray, he put his sandwich on top of it. And that made the complete batch gone. As said, we do a lot of products. It starts with, let's say, communication, personal electronics, again, my field, automotive. What we don't do is military, specific military. If somebody uses in, let's say, this geopolitical situation, we cannot block that, that's for sure. But we don't focus on that. And everything what you can see there, behind it, technology. We have our own technologies, for sure, for some specific products. Some are, let's say, ARM core. We don't redevelop the wheel. No point in that. And our own technologies, especially, again, to automotive, they are quite stringent. We somehow go way back in history and take some technology which was, let's say, already developed, like PCM, phase change memory. Right now, not in this chip, but in our, let's say, even bigger one, we have that. And the challenge is not the technology itself, but to bring the technology to the automotive environment, which is pretty harsh. Just one word about our customers. We have over 200,000 of them. Again, Apple, Bosch, Tesla, SpaceX. But, as said, everything is getting more complex, more involved. So I want to involve also you. So there is a question to you. Do you see any changes in the automotive now? No? No changes? Okay. You all go metro, public transport? Most likely. Okay. I'm surprised by that, to be honest. But maybe I'm too close to the topic, so that's also possible. But let's discover that. Let's find the answer to that question. But I will keep you on the line. I will ask you another one soon, so be ready. iPhone application. I don't mean printf, hello world. No. Let's say standard kind of average application. There we see the space shuttle Endeavour or the other F-35 jet. Standard, let's say, or standard, modern, equipped, average car. And then the last one is actually fully autonomous car. Can you guess, based on the multipliers, times 1, 8, 550, up to 6,000, what will be on the y-axis? Anything? Good? Please. Sorry? Speed of processor, also good. Anybody else? Mr. Fisher, any? Good one. But none of it. It's a line of code. It's a line of code. How many really line of code are in a, let's say, modern car in compared to all the others? And that's again, keyword complexity. That's behind. Let's say to show you, okay, I know maybe you remember Apollo mission was, 8-bit computer, let's say kind of calculator-ish computer. Given also, you need to see it in a bigger picture. It is based on the environment. You don't go and come to your, spaceship and say, I want to go shopping, right? It is point-to-point kind of way. Also in automotive, you cannot go up and down, right? Your space is limited. There is a lot of them. Right now, if we will go to, let's say, standard flights, there's like 10,000 in average over us, worldwide. But cars, 80 million produced each year, or in average again, because COVID made kind of different story, but in average 80 million per year. And that's, let's say, that's the environment we are living in. Right. Because as you said, you don't see any kind of changes. I would like to try to give you some examples. Because the car, at the beginning, it was just, and we discussed that over the lunch break, kind of, going from home to work, from work to shop, from shop back home. That's it. But right now, when we have, this, we are online, we want updates, we want to be secure, the meaning is completely different. It is not the car, the same car that you just start and go, but you want to be, and we want to have it actually, more in a service way. The SDV or software-defined vehicle, for me, it's like service-defined vehicle. It's a, let's say, similar but different meaning. And what also the car makers are going right now, which direction they are going. They want to basically, it's a dream, right? They will sell you right now the car, and over the, let's say, next 10, 15, 20 years, they will give you updates. You will have still your car, which you love, all the dents you made, all the scratches you did, but they will give you all the system, all the environment, or the IVI, the head-up display, whatever you configured, up to date, and you can be sure that no one will most likely steal it. Because if somebody, I think, my opinion, if somebody wants to steal something, he will steal it in, let's say, even in the destructive way. But that's behind, let's say, the services and the future-proof. But the future-proof also means a different topology, different architectures, let's say different approach to the things that before or yesterday they were normal, but in order to be future-proof, you need to do something differently. The hardware has to be there. The hardware has to be ready for those changes to come. And as said, the car architecture, back in the days, you switch the flip, or flip the switch, that's the term, flip the switch, the light bulb went on. But right now, you need to communicate. You have a lot of communication. Again, step number 2 was, just one-to-one connection, or let's say one-to-one communication, not only connection, but they need to exchange some kind of information between themselves. But it was not a heavy load. When the central gateway and all the others came, it is, again, a different story. And that, let's say, explore it for you a little bit more, exploit it for you a little bit more. And we will start where we are kind of, let's say, where we were, then we will go where we are right now, and then what's the future. This is, let's say, kind of a semi-history. Because there was one central gateway, there was a lot of ECUs. Let's say 30 up to 100 plus, depending on your model variant, on your configuration. And this number of ECU heavily depends on a couple of things. First of all, on you, what you configure, what you like. If you like to pay more, you get more. That's let's say there. But not only. It is also the legislation. Really, there is more and more trend to be more safe on the road. So, let's say, e-call. When something happened to you, that the car automatically calls for help. The emergency braking. All these kind of stuff. Pedestrian protection, another one. Driver monitoring systems. All these are adding ECUs. And because we're in a car, not all the ECUs are doing the same thing. Again, based on the functionality. That causes a trouble for the guy in the middle. To write everything from everybody to everybody. This wouldn't go, let's say, far if we will go to the more complex scenario, let's say, be future-proof. So what do we do with that? We consolidate. We consolidate, and we come to what's the status of today. That means we are coming to keyword domain architecture. That's what's on the streets, let's say, right now. What will be also produced for a couple of next years. You put the domain, for sure the gateway still sits in there, but the domain already consolidates, let's say, the main functionality together, put some kind of preprocessing if you wish, and then distribute it to further. Again, nice. But we don't have all the functions so consolidated in the car, right? In front, let's say front right, you want the brake to function, the light to go on, the blinker to indicate, and that's, let's say, the next step. The CP center processor. That's the main guy. And instead of domain, we will go to zonal architecture, let's say. That is what the car makers are working right now, the zonals. And the meaning behind is, inside the car, you will split it, let's say, into 4, 5, which doesn't make, let's say, complete sense, but there's also 5, including the central computer. And in each corner, you will have this zone. For sure, the zone is communicating with the central processor via some backbone. That means high speed Ethernet. 1 gig is not enough. We are going to 2.5 gig and even above. That's being discussed really right now. The thing with that is, because if you go from, let's say, from this spread it all over to this scenario, is that you also reduce the wire harness. And again, to wake you up a little bit, why? You see that a little bit there, right? No? The weight. The wire harness is heavy. It weighs up to 80 kilos. 80 kilos you drag with you, even more could be. And also, it is expensive to make. It is, let's say, the 3rd most expensive part in the car. If we stick with the combustion engine, the engine itself, the transmission, the chassis, for sure, engine and transmission together, the chassis, And third, the wire harness. Plus, for sure, let's say higher complexity in software and the hardware. For sure, the sensors will still be connected to the zone. It is not that the sensors will disappear. You still need that. Sense the temperature, sense the distance, the radar, everything is still outside. The zone is kind of an aggregator still, but in this case, spatial aggregator. Not functional, but spatial. I believe I have quite a lot of questions. What do you think is the enabler? That we can do that we can go this way, that we can pursue this. Also that you can do, let's say, your experiments in a sense. It's basically, no? Should I provide the answer? No? Nobody? Yeah? And if you take it to next steps, the sensor, what's behind the sensors? Also? What, but again, the same question. What's behind the computational power? Yeah? What's behind the microcontrollers? And then I will leave you off the hook. The technology. The technology and also I will tell you later. All is about the change. You know, when I remember our first, not mine, but my parents' first car, it was Skoda 120. You know, at the time, everybody thought it's green, okay. You know, it's safe. You know, it has seat belts front, later back also. Connected AM/FM band. If you wanted more, you need to, you know, scroll down your window to talk to. But for the time, it was good enough. But right now, the expectations are higher. And basically, that's all behind, let's say, this, my long talk, the expectations of you, of me, of all of us. Because the expectations are not going on, so let's say, to all these terms that you see on the slide, but if I summarize that, sometimes we even talk that we want this guy, but on the wheels. The services are there. The security is there. You can pay with that. So I believe we all consider it safe enough because we have money on it or behind it. The updates are there. But the lifetime is not that long as the car. I don't expect that I know people who change this guy regularly. I'm not that much. But that's the key. That's the difference. And also, when there is expectations, there are challenges. And if you want to access that or tackle that, you need to, let's say, approach it from the different angles. And on this one and next slide, I just want to show you, or let's say, to give you some trigger points for you to think maybe later, what are the challenges, in this case, for the OEMs? Maybe I should also explain what the OEM is. We know original equipment manufacturer. Basically, car maker is behind. BMW, again, Ferrari, if you wish. And let me start with, let's pick the electrification, right? It's kind of a hot topic everywhere, especially Europe, China, US also. With the electrification, everything changes. Everything. Because, and I've heard it really from the BMW guys, their all, let's say, popularity is based on, let's say if I translate it, fun by driving, right? That's the BMW. Because that's, let's say, the reaction to the throttle, if you floor it, how that car behaves. But with electrification, and I believe if somebody here is in the e-formula thing, you can confirm that. To drive electrical motor, I don't say it's, let's say, like that, but it is much, much simpler than to drive an engine. You don't need to care about missparks, lambda probe, injection, anything. 3 phases, you go. And on top of that, the way you go, it's linear. The torque, massive torque in, let's say, motor size like that. And everybody is aware of that. BMW is afraid of that because that's something, they lose kind of their thing. And that's why also the services, because they need to compensate it somehow. They need to, they want that you buy it. Simple as that. On top of it, we don't, Jan Wood again, I like the guy, I refer to him a lot, even though I just met him today. The standards all over, not just the emission standards, but all the standards, all the different variants. If you would check on Google just the different charging standards, they're not unified, right? And if they are not unified, the car maker for each, let's say, region, part of the world, has to have that charging standard to be compliant, that you can charge and you go where you want to go. It's just one thing. With that also, for sure, the model variants. Because he needs to track all the model variants, not only based on the standard, based on the equipment, all these things. And with that comes the software and the maintenance. We said we want to be future-proof by the software. Already right now, let's say, as I said, not in this guy, but our biggest microcontroller for the automotive is 20 megabyte of NVM. I know for the, let's say, for the computer guys, 20 meg, that's nothing. In a microcontroller world, that's something. That's one of the biggest on the world right now. From the other perspective, from, let's say, if I will be the ST, from my perspective. And here is the, let's say, second answer, not only the technology, but behind that are the semiconductor products, semiconductor manufacturers. They need to be there, because if you want to be future-proof, that means you need to offer that. And that means be at the right time, with the right product, for sure at the right price. Important now, at the right time. Automotive market is different. And that means in automotive, to be on the right time means 5 years ahead. In other words, if you buy right now a car, it's at least 5 years old, the technology which is inside. Because we have something which is called A sample, B sample, C sample, D sample, and then it's start of the production. Only then. I will not go into details because the time is running, as I see, but maybe next time, and for sure the big data transfer security with that. And the big data and the transfer is, as I said, the 1 gig or 2.5 gig Ethernet backbone with the security. Sometimes we think and we see that the 2.5 gig is really to transfer that amount of data. That's not true always. It's the latency. Microphones, synchronization. Yeah. Also, another change in the microcontroller, or in the, let's say, automotive world, is before there was, let's say, the golden guy, the OEM, let's call it the Ferrari, and there was some tear downs. And then tier 2, aka semiconductors. Because of the change, the development recent also in the market, maybe you've heard Carriot, the software company for Volkswagen. It changes everything, the complete structure. Right now, the car makers, they want to do a lot in-house or they want to do a direct buy. But in order to cooperate with us, they expect from us that we will kind of bridge, in that case, sorry for those, but that we will bridge them and there will be this circle. Let's say that everybody talks to everybody. There is more direct contact with the car maker itself. And that's a huge change. That completes, that, let's say that's changing the rules of the game. Another and last comparison between, let's say, these three, let's say, worlds, consumer, industrial, automotive. I would say the first two and the last lines are super significant. The ambient temperature. In consumer, I don't know, you don't expect it to work at 150 degrees, right? Who would do that? Why would you do that? In industrial, it's a different thing, right? Even for the medical, that's no, not yet. That's the thing. In the industrial, it's a, let's say, wide range. It is from really boring machines to medical, and in that case, also the range is going to minus Celsius. But in automotive, we go, let's say, the full range from the minus 40 up to 125 extended is 150 degrees. That is also why part of this, let's say, overall 5 years product development is also, or are also, summer and winter tests. Plus, as I said, you don't buy your car for 1, 2 years, 5 years, your mobile phone. I don't know how many of you have, let's say, 15 years plus old mobile phone. I have it still at home, you know, the old Nokia, just for, let's say, yeah, I like that phone. But that's it, I'm not using it anymore. Plus, safety. We've heard what is the medical, let's say, fallout of the testing, what kind of is the failure rate. We have less than 1 ppm. That means less than 1 part per million. And we will come, let's say, to the last stage, no more questions, of this presentation, and that is, let's say, the real applications. Something I will relate to that in a sec. And that is, let's say, what is really in the car. And this board, right now we know what the domain is. This is a body domain module. Is in each and everybody BMW right now on the street, let's say, within that period. It is taking, as you can see, a lot of inputs, a lot of outputs about the body functions, you know, lighting, not steering for sure. It's a lighting, interior blinkers, also, you know, all these kind of thing. Set up your seat, these kind of, let's say, applications. But what is important and to see here is this, or are these melting fuses. This is the story, let's say, up till right now, and that is the future. But that's what you can see right in front of you is this one. And that means that the fuses, you know, they work. The problem is, as we know, the wire harness is heavy, it's expensive. And because the melting fuses, they're slow, you need to over-dimension that. You need to thicker wires, let's say, to be safe. And that's why everybody right now looking into this. It's a power distribution unit. Basically, you replace the old melting fuses with the semiconductors. Those semiconductors can have pre-programmed I²T curve. They react super fast. They have diagnostic. You can control them. And I believe you've all noticed that if you take your, I don't want to call it DC-DC, but basically that's what it is. And if you plug it into the socket, there is sometimes a spark coming, right? Because it has high input capacitor. And with these guys, you can precharge it. So there is no such a thing. You can control it in a way that you want. It's coming for sure with the challenges, because you see more than 100 amp. On the board over here, you will see 170 amps. Because this will be in each, or mostly in each zone of the car, and it will distribute the power to those ECUs that you need. Because your power in the battery is limited, if you will go down, you can shut off with this one, control in a control manner, the ECUs that are not necessary for you to drive. And that's also the added value. Next thing, second thing from the electrification, the BMS. And my, last question. What's the main purpose of the battery management system in either hybrid, plug-in hybrid, or electric car? Please. Very good. Very good. That's the one. It is actually there to protect the battery. Plus, for sure, give you the range. But if you, let's say you've seen, right, Tesla's burning all of those. He's the guilty guy. That's one. Because there's, for sure, sometimes there are also physical effects behind it, something called thermal runaway. That means if one cell out of the hundreds inside your battery pack is gone, let's say is broken, it can, let's say, reach, we can call it critical mass, start burning, and you cannot stop it. You really cannot stop it. There are certain methods, we're working on that as well, electroimpedance spectroscopy, how to inspect the cell, the inner of the cell. But really, very good point. What's your name? Nice. And then, again, basically, taking care of the battery, evaluating the state of X, that means charge, health. On the health, again, standardization, we don't have that. That's again problem because everybody's talking second life of battery to, let's say, take the battery of the car, use it at home. But if you want to buy a rabbit in a hole, okay, right now it's the situation. If we would like to have it on a, let's say, manner, okay, this battery is 95%, that one is 80%, this one is 70%, we need a standard for it. And that's also what's ongoing. Plus, all the information coming from the battery, they need to be super synchronized. Because you cannot, let's say, sample them at different levels, also the current sense, everything has to be synchronized. And that's part of, let's say, and the requirement basically of the green boxes to deliver you the resolution, the synchronicity, and the precision. Basically, resolution with that. Last topic, finally, security. If you, right now, are old-fashioned as I am, you still have this guy, right? Come, open the car, yeah. You need to press the button. And let's say, in the future, or if you, let's say, even now, right now, buy it, you can do it just, by the keyless entry, as it's called, the system. Everybody calls it this way. And there is a new way of, let's say, doing that more secure way. Because right now, if you have the old system, you can have a replay attack. You've seen that maybe on the videos. Somebody is near to your, let's say, key fob. He has the replier. Let's say it works like an amplifier. And another guy opens your car, and it can be pretty much anywhere in the world. With this new approach, not anymore. Because also, your mobile phone will need a UVB, ultra-wideband chip. There will be, let's say, secure communication behind that. And it will be on a higher security standard. Because right now, only thing which was up till now was the BLE, Bluetooth Low Energy, which is providing your certificate. There was, let's say, a handshake, and it got open. What the BLE, which is in those 4 anchors, gives you is, first of all, the ranging. It kind of behaves like a radar, so it knows where you're coming from, let's say from which direction, which door to open. Plus, it is a secure communication on a higher standard. So there is like, you can see it kind of like two-way authentication in this case. And in this way, the replay attack will not work anymore. And that brings us to the final slide. And that is this hub. Because as I said, from the manufacturing, from ST point of view, you can find us here, you can find us here, there. Also in a couple of your works, we can find ourselves also. And you can find us in each car on the street multiple times, at least 20 times. Thank you.
So thank you for your presentation, and now we have space for some questions and discussion. So if you have some questions, feel free to ask Mr. Pistulka. Yes, you can.
So do you use other from different suppliers in your...
Supply for...
Like you said that 100 semiconductor device are like currently manufactured by SD.
No. That we have our own manufacturing sites.
Yeah.
We don't do, for sure, let's say, there are different technological nodes, right? You have 28 nanometers, in Intel 4, 7, whatever. And to have a manufacturing site, as I said, is not, let's say, like that. You cannot build a new manufacturing node, new manufacturing sites overnight, and it's expensive, and you need to keep it really loaded. So from that point, for sure, not 100% we do in-house. That's not like that. Sorry if I present it like that, then my bad. No, it's not like that. We also, let's say, work with others, like the TSMC, for example.
Thank you.
Thank you too.